In this lesson, I'll show you how to find the empirical formula from combustion analysis. The first question reads, upon combustion, a compound containing only carbon and hydrogen produces 1.83 grams of CO2 and 0.901 grams of H2O. Find the empirical formula of the compound. What we want to do first is find the molar mass of CO2 and H2O. And we can do that by using the following molar masses for each individual atom within these compounds. Let's start with CO2. We have one carbon represented by the letter C, and it has a molar mass of 12.01 grams per mole. It also has two oxygens at 16.00 grams per mole. Using our calculator, we have 12.01 times the amount of carbons plus 16.00 times 2 oxygens. And this gives us a molar mass of 44.01. Now let's find the molar mass of one molecule of H2O. We have two hydrogens, and hydrogen has a molar mass of 1.008. By the way, these can all be found on your periodic table, grams per mole. And we have one oxygen. Oxygen has a molar mass of 16.00 grams per mole. Using my calculator once more, I have 1.008 times 2 plus 16. And since we only have one oxygen, I don't need to multiply this. We get 18.01. Now that I found the molar masses, what I will do is take this number and multiply it by the reciprocal of the molar mass of CO2. By doing that, I'll end up finding the amount of moles of CO2. Here's what I mean. I'll take 1.83 grams times the reciprocal of this. So instead of grams at the top, it will be at the bottom. Multiplied by 1 mole over 44.01 grams. Look what happens here. This gram unit will cancel out with this gram unit, leaving me only with moles. The same thing will be done with water. I'll take 0.901 grams and multiply it by the flipped version of that. 0.901 grams times 1 mole at the top and 18.01 grams at the bottom. The grams unit cancel out, leaving me with the amount of moles. Using my calculator, 1.83 divided by 44.01, this gives me 0.04158 moles. And I'll put a dot underneath the last significant figure. Notice that this had 3, so we should also work with 3. But I'll keep the 8 just to prevent any sort of rounding errors. 0.901 divided by 18.01, and that gives me 0.0500. 0.0500 moles. Now, using these two very important numbers, I'll start with this one. I'll multiply 0.04158 by the amount of carbon moles within 1 mole of CO2. Notice that there's one atom of carbon within 1 molecule of CO2. So I'll take 0.04158 moles of CO2 times 1 mole of carbon over 1 mole of CO2. This gives me, this mole unit cancels out with this mole unit, 0.04158 moles of carbon. Don't forget the dot underneath this 5. And now I'll do the same thing for hydrogen, but using this number. I have 0.0500 moles of H2O times 2 moles of hydrogen found in H2O within 1 mole of H2O. The mole units cancel out, and I'm left with 2 times 0.05. And this equals to 0.100 moles of hydrogen. I'll highlight these two numbers, this one and this one. Now we're told in the question that upon combustion, a compound only contains carbon and hydrogen. So the empirical formula should have C and H, and we found that the moles of carbon equals to 0.04158, and the moles of hydrogen equals to 0.1. These numbers are not integers. We do need integer numbers. We need natural numbers here. And to make these decimal numbers into whole numbers, I first need to divide both of them by the smaller of the two. 0.04 is the smaller of the two, so I'll divide this number by 0.04158. That makes into a 1. And divide 0.1 by the same thing. Let's go ahead and do that. 0.1 divided by 0.04158 gives me 2.4. So that becomes 2.4. So technically we have C1H2.4. And now you have to multiply this whole equation by a factor that will make 2.4 into a whole number. The best way to go about finding that number, that factor, is to convert 2.4 as a fraction. Now my calculator can do that for me. If I type in 2 over 4, I get 12 over 5. But in case you don't have this capability on your calculator, 2.4 is the same thing as saying 2 and 4/10. And this can be reduced down to 2 and 2 over 5. Changing this mixed fraction into an improper fraction, we multiply 5 by 2, which is 10, and you add 2, and that's what our calculator gave us, 12 over 5. So you multiply both the C and 2.4 by 5, and you should get whole numbers. Multiplying this by 5 gives me 5, and multiplying this by 5 gives me 12. So our chemical compound, our fuel here, is C5H12. Now, if you would like to see the answer to question number 2, make sure to watch question 2 of this series, and that is how to determine an empirical formula from combustion analysis.